can you extract the salt from this solution? Extract the salt? Yes, very simple. How is that? This is crystallization. This is simply crystallization. And how do you do this? Just you first heat the solution, and when you heat, then the volume will decrease. Water, you are reducing water, volume of water. Okay. Then after this, you will get again, but with less volume. All the salt will remain there. Salt will remain there, but less water. What do you call this solution? Concentrated solution. What do you call this solution? Dilute solution. So dilute solution has been concentrated. Okay, you can put a glass rod, and you will get glass rod gets some crystal deposits on it. So some crystals will deposit here, and you understand that yes, this is okay. This concentration is okay. Now what you will do? The first step one was this, and second step is cooling. Cool the solution. When you cool the solution or leave for cooling, then you will get crystals. Okay, simple. You will get crystals. So what's the next? Very simple. You filter. What I suggest, don't write just filter. Better we say filter with filter funnel and filter paper. Better. Understand? You use for mark for this. Then what you will do? Then I will not wash the salt. Can you wash the salt? Suppose the salt will have some impurities. Should you wash the salt? No, you can't wash the salt.
No,
if you
sir.
wash, salt will be dissolved away. Okay, you will lose the salt again. Again, you will get the solution like this. So better. A third step, what I say, filter. You filter the salt and just dry. I do filter with filter funnel and filter paper. And how do you dry? Say at room temperature or by evaporation or by without heat. Some of you right. So these are ways how you filter, how you dry. You should include there. So this is simple technique of crystallizing salt. This you learned in the first chapter, state of matter. Now come on. When you make a salt in chemistry lab, then you will not get the salt solution. You have to first make the salt solution, then you need to crystallize this. Understand? You know, we get salt, stable salt here from seawater. We get salts from seawater, and seawater already contains large amount of salt, so we just crystallize. But in the lab, in the chemistry lab, you need to make the salt solution, then you need to crystallize. But if the salt is soluble, if the salt is insoluble, you will not get solution, and you don't need to crystallize the salt. This process is even simpler. And remember this, when you make the salt in chemistry lab, you make the salt and then you will crystallize. Two things important. One, you should make the salt, final salt should be pure. Okay, pure. And second step is, when you make the salt, that should be crystalline, not powder. Okay, these two are conditions. So as the salt is soluble, so here's a big problem, big issue. When you filter out the salt, filter out with the filter funnel, you filter out the salt, and you get here the salt crystals. If the salt contains some impurity, it's very difficult to remove them. Removing impurities is difficult. Why? Because you cannot wash out the salt. If you go for washing the salt with distilled water, you will lose the crystals. So this is the problem. How to solve this? You will first make the solution, and then you will crystallize. As the crystals cannot be washed away, so better you make the solution pure. Make the solution pure. What does it mean? The solution should contain water. Certainly this will contain water, but only the salt. Water and salt. Okay? If this is pure, then we call the solution is pure, not having any other impurities. Then when you crystallize the salt and separate, then you will get pure salt. So now look at this. How to make the pure salt solution. How to make pure salt solution. What is pure? That doesn't have any acid, doesn't contain any alkali. With two ways to make a pure salt solution, depending on what you are using. If you have an acid, and alkali to make a salt, suppose it could be hydrochloric acid or sulfuric acid or nitric acid, etc. Many. If you get an acid and alkali and you want to make the salt solution, it should be pure, then what should you do? Yes, this is very simple that you will first carry out the titration. Why is titration? Is this to make pure salt solution? No. If this is to understand, equivalent volumes. What volume of acid is equivalent to what volume of alkali. That is, when the titration is over, you'll get just volumes. Certain volume of alkali and certain volume of acid. Okay, one is with pipette, another with burette. Okay, we normally carry out the titration several times so that we get concordant result and we average the concordant result. Ultimately, we get the titer. So after titration, we get equivalent volumes of acid and alkali, right? But the solution you have made in the titration is not pure. Why is not? Because that contains indicator. This is colorful indicator. So this is not, that is not pure salt solution. So what you should do, simple, you discard the solution in the clinical flask. Then just remake the solution. Again, mix them. Acid and alkali, mix them again at the same ratio as you get in titration. You have got this acid 25 cm cube, alkali 20 cm cube, or any other volume. So according to the ratio, 20 and 25 could be or any other, you are mixing them together again. Just mix them together again, and you will get the pure salt solution. This time you should not add any indicator, right? This is very simple. And this is the way to make pure salt solution. But what is your problem? Your problem is you should be clear about your reagent. You have acid and alkali. When you don't have an acid and alkali, but you are going to make a pure salt solution with any other reagent. Could be acid and solid, insoluble solid. The solid could be metal, suppose zinc or copper, or could be metal oxide, suppose this zinc oxide or copper oxide. Okay, and how to make a pure salt solution with them? You got acid and solid, then you cannot carry out titration. So what you will do? Just get a beaker, very simple. Just get a beaker and get the acid. The volume is not so important. Get this volume. Half of the volume would be enough. This should not be full to the brim because you are adding solid here there. So now you got the acid, and warm acid is good because warm will fasten the reaction. So now gradually add the solid, small by small pieces. Gradually add the solid, and you will get that solid will disappear. The solid will disappear. Why? Because the solid reacts. When the solid reacts, that forms the salt. The salt is soluble. You may add more solid, okay, and wait and stir and wait. That may again disappear. And after some addition, you will get the solid remains there. Some solid remains there. What do you understand? Then what do you understand? You understand that the acid has reacted. All the acid has reacted. No acid is there. So when no acid is there, is this pure? What do you think? When no acid there, is this pure? No, because some solids are still there. Okay, some solids are still there. So how to remove the solids? Just filter. Okay, the next step, just filter with filter funnel and filter paper. So the solid you are going to remove the solid by filtering the solid. Okay, just what you will get here? What do you get here? Yeah, ultimately you get just the solution. Is the solution pure? What do you think? Is the solution you get pure?
Yes, sir.
Yes, sir.
Does it contain any acid? Does the solution contain an acid?
No, sir.
No,
Does
sir.
it
No, sir.
contain any solid or anything else? No, nothing.
No, sir.
Because
No, sir, nothing.
excess of solid has ensured that all the acid has reacted. 1, 2, and filtering has ensured that your solid has been removed. Okay, just get the solid solution. So this is how you get the solid solution. So we got two ways. You got two ways to make the solid solution, pure solid solution. Then what you will do? Then what's the next? What you will do? You just now crystallize the solids. How to crystallize? First you heat, and after you heat, you will reduce the volume to make concentrated solution. This is what we call up to the point of crystallization. When up to the point of crystallization, you make concentrated solution. Then you just cool, leave for cooling. you will get the crystal deposit at the bottom of the container. Then what's the next? You filter to get the crystal separated. And after you separate the crystals with filter and filter funnel and filter paper, then you need to dry. And you should not heat to dry the crystal, because heating may break the crystals, break the lattice. So this is a way of making soluble salt. I may give you two examples for these two processes. One is, suppose you have sulfuric acid, one you have sulfuric acid, another you have potassium hydroxide. So this is one. And another maybe you have sulfuric acid, another is with copper oxide. So this will make potassium sulfate salt, and this will make copper sulfate salt. Both are soluble salt. And now we apply. Which process do you pick for this first one, potassium, to make potassium sulfate solution? Which, second one or first one?
Titration.
Titration. Titration.
Why is titration for making potassium sulfate?
So because acid and alkali.
Acid and alkali.
Right, acid and alkali, and with acid and alkali, you need to know the equivalent volumes before you mix them together. So this is one. And then another, what you get here, potassium, sulfuric acid, and
Neutralization.
You take the warm sulfuric acid, add excess copper oxide gradually until all the acid is reacted. Then you remove, filter to remove the remaining solid. You will get the salt solution. And after that, you can easily crystallize the salt. This is finished. Now we are going to make another salt, another type of salt, which is insoluble salt. Insoluble salt means you make the salt and you get the salt. You don't need to crystallize the salt because the salt is insoluble. Like when you add some sand in water, because sand remains there. Why? Because it's insoluble. So when you make insoluble salt, you will get the salt ready. So this is simpler and easier way to make the salt. But one thing is very important, that is condition. When you make an insoluble salt, you should pick the reactants, mix two reactants. They should be liquid or aqueous. You understand what is the condition? This is the condition. Normally, they could be an acid, okay, could be an acid and alkali. Alkali is okay, can also be there if they make insoluble salt, or could be acid or another salt or carbonate salt, etc. The main thing is both the substances should be aqueous, or could be two salt, salt another salt, salt another salt. You're mixing. When two salt reacts, they form two more salts. Okay, I'm giving examples. Suppose you are getting here silver nitrate. Isn't this a salt? Yes, salt. Silver nitrate is salt, and you get aqueous. Okay. Then I'm going to add here hydrochloric acid. And if this two reacts, what you will get? You will get a salt which is silver chloride, and the salt is solid. Why is the salt solid? Because this is insoluble. Yes, of course you get another thing there, which is the nitric acid, HNO3. Nitric acid you will get along with this. Look, this is a double displacement reaction. Silver displaces hydrogen here to make silver chloride. So this is soluble salt. There are many other examples. This could be sodium chloride. Suppose sodium chloride. This is silver nitrate and this is sodium chloride. If they react, you will get silver chloride, solid, and you will also get sodium nitrate, which is aqueous. Okay, so again I repeat, the condition should be when you make an insoluble salt, you must pick these two soluble or aqueous. Okay, aqueous. You are mixing them together and you will get. So how to make this? This is simpler way. Here you get a salt solution or acid solution. I'm using here silver nitrate. Suppose here silver nitrate dissolve in water. That was the condition. And get another here. This could be sodium chloride. You know, sodium chloride is a soluble salt, and that should be there, dissolved in water. And when you mix them together, what you will get? You will get a solid. What's the solid? This solid is silver chloride. Because this is insoluble, you will get the solid. And what you will get? Sodium nitrate. Sodium nitrate. This is still dissolved. Look, this is still dissolved because it's soluble salt. So you already get this salt ready. Isn't this a better way? Okay, better way. So now what you will do? You just use the filter funnel and with the filter paper and separate. Okay, just filter. You'll get the crystal here. Crystal here. Is the salt you get here pure? Is the salt you get here
No.
pure or
No.
it's not supposed to be?
No, sir.
This is not supposed to be pure because you are adding this solution without any volumetric analysis. You don't carry out titration, and this is not possible. They are not acid alkali that you are carrying out titration. And then you are not estimating their volume or amount. You just mix them. Okay, when you are just mixing them together without any analysis, estimation, then one of them must have been more than other. So that will remain, that may remain there in the solution. And then another substance formed with silver chloride, which is sodium nitrate. So sodium nitrate will also be in the solution. Okay, so just one of them will be there in the solution, and the byproduct sodium nitrate will also be in the solution. And when you filter, yes, the filter, they are soluble, they have gone through there that the solution, the solid, but the solid may have little amount of the solution or little amount of the salt. How to remove the impurities or purify the salt? Yes, wash with this fluid. Already filtration is already complete. Now just you spray water. If you spray water, the water will remove any impurities with the salt. This is possible because the salt you have made is insoluble, which means if you spray water, that will not dissolve. And the impurities, possible impurities are soluble. So you get this, just you spray water and the impurities will be washed away and you will get the pure salt. Then what to do with the pure salt? Just dry. Dry in the same way as at room temperature without